Welcome to Education Online program. I am teacher Willa Lucia. So in our previous lesson, we talked a lot about surface tension. We talked about the definition of surface tension, the effects of surface tension, uh, and so many other things. So today we're going to be learning about something very different, which is the mass and weight. This is our mass and weight. So if we look at mass and weight, most of the times we tend to think that these two are similar. When someone is talking about the mass of an object, you might be thinking that they are talking about the weight of the object. But in actual sense, these two are different. Of course, they are related to each other in another way, but then they are not similar. Let's look at mass. And then we check the definition of mass. We say that the mass is the amount of matter an object contains. Let's first put this definition down. Is the amount of matter an object contains. If we are to look at this definition, let's look at the definition of weight now. So we can define our weight as the force exerted on an object by gravity. That is the first difference we can see there. We are talking about this one, the mass being the amount of matter. But then look at weight. A weight becomes here as the force. So this is how these two are not related to each other. But then to some extent I said they are also related. But then we shall see how the relationship between the two as we go on. But if you look at objects on the surface of the earth, each and every object has got the weight. That means that it has mass. So, but in other words, you'll find out that some objects, their weight or the mass is very hard to be measured. Why is that possible? Let's take a look at any other object floating on the surface of water. What happens? So that one will take us to the weightless objects. So let's look at any object floating on the surface of water. Object floating on surface of water. So if the object is floating on the surface of water, can we say that that object doesn't have weight? Can we say that the object is not having any mass? No, this object has got the mass. But what happens is that when it is on the surface of the water, the weight, it transfers all its weight down to the bottom of the water, because that is where pressure increases. Because if you look at pressure, we said pressure increases with depth. So as this object is on top of water, trying to show you that it doesn't have mass, no, it has. But then all the mass, the weight on this object has been shifted down to the bottom of the water. So this is why you find some objects floating on the surface of water looking as if they do not have the weight. Let's look at another example, a balloon. So if we have a balloon, let's try to add pressure into the balloon. So if the balloon has pressure inside it, you'll find out that this air inside the balloon and the balloon itself, when you throw it up, it tends to just fly around in the surface, in the space. Why? It doesn't mean that this balloon doesn't have any weight. This balloon has got weight even with the air inside it. So you'll see that it is not that you will get the balloon and start weighing it too. Of course, if you do that, you will get the mass. But then let's see that this balloon, why is it that it goes to the space? Why is it that it doesn't fall down back onto the ground or the earth's surface if we say that it has weight? This is because it is being buoyed by the air. So it distributes its weight, or it distributes the mass in it to a very wide area. So as it occupies a wider area, that means that the weight, the mass in the balloon will tend to be weightless. That's why you see that a balloon is in position to just fly or in space. So let's take a look at another example, the aeroplane. We can have it here as our plane. You see that a plane can fly. It goes up the air without falling back down. This plane here has weight. It is very heavy, yes. But then what is that effect, the factor that makes it go, that makes it fly without it being pulled down by the forces of this gravity here? Since we say that weight is a what? Is a force exerted on an object by gravity. So we expect if the plane is up, it should be experiencing this gravitational pull. So you'll see that this aeroplane here the weight does not just disappear, but then the weight is being distributed to a wider area. So if it is in the air, that means that all its weight is being distributed around. That's why you see that it is in position to be up without falling down. So let's take a look at the relationships between mass and weight. We have our relationship between mass and weight. What is that common thing that you can find in mass and weight? So we know that this mass and weight, they are closely related, even though we say they are not the same, but still they are closely related. Why? Because you find out that this relation is because mass affects the weight of an object. How does it affect the weight of an object? In a way that if this object is experiencing a force of gravity, that means that the mass there is trying to affect the weight, because we say that if you look at the weight, it is just a force which is exerted by gravity. So you'll see that if this mass of the body has acceleration due to gravity or the gravitational force acting on it, and it depends on the extent of the amount of this gravitational force acting on the body. So it means that if there is any change in this gravitational force, that means that there would be change in the weight of the body. So for us to find weight, we need mass, because it is this mass here now to determine how heavy this object is. So if you now add them, if you get the mass of that object and then you multiply it by the gravitational pull of that area, you'll find out that you're now getting the weight. So that is the relationship, meaning that to get weight, you need to know the mass of an object. So let us write it there. The mass affects weight because of our gravitational pull. So now there, that is how these two are related to each other. Then you'll also find out that weight is the measure of what? Of force of gravity. But then if you look at the mass, it turns out to be the amount of matter. That means that there are also differences between the mass and the weight. So let's take a look at the differences. We can have our differences between mass and weight. So if we are talking about the differences, we are talking about how these two are not related to each other. So it is not a must that you'll find only the term differences. They can also tell you to distinguish. When they're telling you to distinguish, they are telling you to show how these two are not related. So let us see how mass is not related to weight. So we can have, let's have it in form of a table. So in this case, we shall have our mass here. And then let's look at our weight. Right in that corner. The first differences you're going to find between mass and weight will come from their definition. Because already the definition alone shows you that the two do not relate. They are not related. They are different. So you can just look at the definition and check. We are saying that the mass is amount of matter. That means that mass is a property of what? Is a property of matter. So we can have it our mass is a property of matter. If we extracted this difference right from the definition, so what do you think will be that if this one is the difference and the mass, what will it be and the weight from the definition of weight? We shall say that this weight here is just a force of gravity. So we can see that the difference here is that if you're getting the weight is just a force of gravity. So that means that we are using our definition to get our first difference between the two. So we also have another difference. If you want to know about mass, mass does not change with location. Okay, we can say that it does not change with location. How does it not change with location? We mean that whether the object is up in space or the object is on the Earth's surface, this mass is going to remain constant. It will not change. It will change in a way that maybe if you get another object and add it on top of the other object, that means that you're adding a mass of another object on top of the mass you already have of this object you measured. So, but if you do not do that, you can measure you can get my mass right here on the surface of the earth, and then you take me up maybe on a cliff to try to get the mass again. You'll find out that the mass is still the same. So it means that even though you go to the valley or where, or even weighing it on the surface of water, that mass will not change. The mass of the object will always remain the same. But let's look at weight. What will happen? The weight here changes with location. So how does weight change with location, yet the mass does not change? This is because the gravitational pull that is acting on any object depends on the location of this object, because not all locations have got the gravitational pull as 9.881. So you'll see that this mass here does not change. We said when you want to get the value of weight, or you want to know the weight of an object, you'll have to multiply the mass and the gravitational pull. So you'll see that if the mass is constant and there is change in the gravitational pull, that means that obviously the weight of the object will change. Because if here I multiply if I have a mass of 10 kilogram, let me assume here there is mass of 10 kilogram, and the acceleration due to gravity of that location is 5. How would you know weight? Our weight will be the mass we know times the gravitational pull. So we shall have our 10 kilogram times the 5. This is meters per squared second. So if we have it like that, that means that in that location the weight of that object will be 50 newtons. What if now we take it to another location where the acceleration due to gravity is 10? That means that we shall have our weight, which is equals to the same mass, does not change, which will give us our 10 times the gravitational pull of that location. We assume that it is 10. So that means that in that place our weight will be 100 newtons. You see, it is the weight, the mass of the same object we are using, but in different locations, and we are getting different weight for the same object. That meaning that our mass will change as the acceleration due to gravity of that location changes. So let's look at another difference between the two. We say that a mass is a scalar quantity. What are these scalar quantities? We say this scalar quantity, they are quantities that have got only the magnitude without direction. What do we understand by the term magnitude? The magnitude means that the size, okay? That means that an object that is under scalar quantity, which is a physical quantity in science, has only the size. That's why we are saying matter is the property of mass is the property of matter. It only has the size. It doesn't have the direction. So I cannot come and say that this thing is the mass of this is maybe 2 kilogram. I cannot say it is 2 kilogram moving to west or to south or north. I'm just talking about the mass. So that means that a mass only has magnitude, size, but you cannot, it doesn't have the direction to which it is facing to, or it is moving to. So that's why it is a scalar quantity. Now let's take a look at weight. Our weight is a vector quantity. Vector quantity. Why is weight a vector quantity? Weight is a vector quantity because weight has got magnitude and direction. So the magnitude, the size of the weight comes about because of the mass. Because we say the mass is a scalar quantity, it has only size. That is how this magnitude in weight comes about. What of the direction? We say that weight is what? Is a force. And a force moves in a specific direction. So that is how the element of direction comes about with weight. So we can say that you can have like this. If you have maybe you're trying to pull this car. Let me have a simple diagram here of a car. We assume something like this, like that. That is our car, which is more like a house. So if we assume this is the car, what happens is that if this car you want to give it a pull, you are applying a force. So let's take we are pulling it that way. That means that we are pulling it. We want to release it downwards here. That means that you're already pulling this weight. If the car is weighing maybe it has a mass of 100 kilogram, you're pulling it downwards. That means that the downward is already the direction to which the force is being applied. So that is why we are saying weight is a vector quantity, because it can describe for you how much the object weighs and to what direction is the object being taken to or pulled. So that is another difference between the mass and the weight. Let's look at another difference here. We can say that a mass can never be zero. Can never be zero. Why can't mass be zero? You cannot tell me that already after weighing this, I get the mass, and then I take it to another place, I say the mass of this is already zero. No, the mass of an object can never be zero. But what of the weight? Weight of an object, weight can be zero. Why do we say weight can be zero? Yet we say that to get weight you need the mass, and we are saying mass can never be zero. This is because not every point or every location has got acceleration due to gravity. So you'll find out that you'll reach a point where there is no gravitational pull at all, and you just find that objects just fly around on the surface. This is because at that location, at that point there is no gravitational pull. That means gravitational force, the gravitational pull there is equivalent to zero. So when something is zero and you multiply it with a number, what happens? You will get the answer as zero. That's why we are saying that the weight can be zero. Let's look at this when it is in form of calculation. We are having maybe our our mass of an object or satellite, we can say it is, let us talk of 200. The satellite is weighing 200 kilograms. We want to get the weight of this satellite. But then our satellite is beyond. It is at a point where it has been given what is known as the escape velocity, where there is no gravitational pull. So if our gravitational pull at that point there is 0 meters per square second. Now what happens to the weight? If we want to get weight, we say our weight is equals to mass times the gravitational pull. So here our weight will be our mass, which is 200 already we got, times the gravitational pull at that point, which is 0. What happens is that this 0 here will cancel the whole of this 200. It dominates the 200 figure, meaning that our weight will be 0. So that is how a weight becomes 0, provided it reaches a location where there is no gravitational pull. So let's look at another difference. So if we have, it is just a continuation of that, but this time the space right there isn't enough. We pull it right here. Okay, something like that. We have our mass still, and then we have the weight. So here we already have very many differences. Let's try to add. How do you measure mass or weight? You'll see that the measurement of mass and weight gives us another difference between the two. How is that? You'll see that mass can be measured. Mass can be measured using ordinary balance. If it is measured using ordinary balance, can you use the same ordinary balance to measure weight? No. So that is how it also comes there as a difference. So our weight is measured using we can say is measured using a spring balance. So you see, to get this difference between the two, you just look at it. To get the difference of two things, you don't need to go and look for very big things, like very big differences between them. But even the smallest difference counts. Like the measurement, you might not know that it is also a difference. Not only that, there are more differences, like the units. You can see that the mass of an object is measured, and the unit is what? The unit can be gram or kilogram. And then the weight is not having the same unit as mass. So you see that one counts as a difference. The weight comes there with the unit as what? As Newton. Why? Because weight is a force. Okay? So for you to get the difference of two objects, you don't go very far looking for very big things, but even the smallest, you can add it there as the difference. So these are not the only differences that are in between mass and weight. There are so many others. As you go on, we shall find more about that. So since today we've learned a lot about mass and weight, I hope now you've known that the similarities or the relationship between the two, And you can now define a mass, and you can also define the weight, because most of the time you find people saying defining a mass as the weight of an object. Then in other words, you find they also just change to say that weight is the mass of an object, which is not that case. So we have seen the definitions of mass and weight. Even you've known the relationships and the differences. So I hope you keep that right at your fingertips, because anytime if someone is to ask you, you won't be saying mass is the weight of an object or weight is the mass of an object, because those are not correct. So thank you for attending with me. We shall meet again in our next lesson.